डियर स्टूडेंट्स, एसएससी जेईई पीवाईक्यू सीरीज के इस सेशन में आप देखेंगे इलेक्ट्रिकल मेजरिंग इंस्ट्रूमेंट से पूछे गए सवाल जो कि एरर एनालिसिस टॉपिक से होगा। आप एरर एनालिसिस टॉपिक से पूछे गए सभी प्रीवियस ईयर क्वेश्चंस के ब्रीफ सॉल्यूशन देखेंगे विद प्रॉपर एनालिसिस। सो हैव पेशेंस, वॉच द कंप्लीट वीडियो एंड देन ओनली यू कैन गेट द मैक्सिमम बेनिफिट। सो सी ऑन स्क्रीन नाउ। Okay, so see here, 2 meters X and Y required 40 milliampere and 50 milliampere respectively for full scale deflection. Then it is asking for the sensitivity of X and Y. Means here there is a comparison of sensitivity for instrument X and Y. Sensitivity is equal to 1 by IFSD. Here IFSD for meter X and meter Y is given as 40 milliampere and 50 milliampere respectively. So SX would be equal to 1 by 40 and SY would be equal to 1 by 50. Here you can say, you can compare SX and SY. So SX would be greater than SY. So answer would be X is more sensitive than Y. Next, a DC voltmeter has sensitivity of 1000 ohm per volt when it measures half full scale in 100 volt range. The current through the voltmeter will be. See, sensitivity of the voltmeter is given irrespective of whether it is voltmeter or ammeter. The IFSD value of the instrument is given by 1 by sensitivity. Sensitivity is given as 1000 ohm per volt. So IFSD would be equal to 1 by 1000 ohm per volt. It would give 1 milliampere. So 1 milliampere is the full scale deflection current for this particular DC voltmeter. It is asking to calculate the current through the voltmeter at a half of the full scale would be. At half of the full scale, the current through the voltmeter would be half of IFSD would be equal to half into 1 milliampere. That would be equal to 0.5 milliampere. Next you see here a 150 volt moving iron voltmeter of accuracy class 1.0 reads 75 volt when used in a circuit under standard conditions. The maximum possible percentage error in the reading is. So it is given, so accuracy class of 1.0. Accuracy class of 1.0 indicates the guaranteed accuracy error. So here GAE, that is guaranteed accuracy error, is given as 1%. 1% of guaranteed accuracy error actually means that manufacturer is giving guarantee of 1% of error. Guaranteed accuracy error is calculated based on the full scale value or IFSD or VFSD value. So here it is 150 volt moving iron voltmeter. 150 volt is the full scale value of the voltmeter. So guaranteed accuracy error, that is error in the instrument, would be equal to 1% of 150, that is equal to 1.5 volt. Now see, it is asking to calculate here what is the possible percentage error in the reading. The observer has to read or has to take the reading for the measurement of 75 volt, meaning is what? True value is given as 75 volt. So percentage relative static error is equal to absolute error divided by true value into 100. That is 1.5 divided by 75 into 100. It would give result as 2%. So 2.0 would be the correct answer here. Next, the voltage of a circuit is measured by voltmeter having input impedance comparable with output impedance of the circuit, thereby causing error in voltage measurement. This error may be called, so answer would be loading effect. Such error is nothing but error caused by loading effect. The next problem is from the date time. The date time of an instrument refers to, say, the definition of the date time itself, time before the instrument begins response after the quantity has altered. So this would be your correct answer here. Remember, this is itself the definition of the date time. Next, in which of the following do the measurement, find their application. See the statements, there are three statements given here. The correct answer is 1, 2 and 3. Is one. Automatic control of process and operations is also a correct statement for the given problem. Engineering experimental analysis is also correct. Monitoring of process and operations is also correct. So all the three statements are correct with respect to the given problem. Next, error which may be variable both in magnitude and nature, positive or negative. This is what your random error. Next, the measurement of surface temperature in exposed situation when atmospheric variation can interfere with a temperature measurement gives rise to. This is what the interference error. Next, what represents the departure of observed reading from the arithmetic mean of group of readings? This your deviation. Next, determine the value of current in milliampere required for the full scale deflection of voltmeter when the sensitivity of voltmeter is 125 ohm per volt. See again here the sensitivity of the instrument is given, that is 125 ohm per volt. You know IFSD is equal to 1 by sensitivity. Just you take the inverse of 125. So 1 by 125, this much of ampere, you can convert it in milliampere, means multiply it with 1000, you will get 125 divided by what? 8. So 8 would be the correct answer. 8 milliampere would be the IFSD value here. Next, the current required for the full scale deflection of voltmeter is 10 milliampere. Find the sensitivity in ohm per volt of the voltmeter. Just you have to take the inverse of the full scale value of the current. So S is equal to 1 by 10 milliampere. So you convert it in terms of your what? Ohm per volt you have to convert. So you convert milliampere into ampere, means multiply 1000 here. So you'll get answer is 10. Next, if a zero centered voltmeter has scale from minus 5 volt to plus 5 volt, then the span of it is. See, a span of instrument, particularly for zero center type instrument, is equal to difference of the maximum value and minimum value. Here the maximum value is plus 5 volt, minimum value is minus 5 volt. So take the difference, 5 minus of minus 5, meaning is what? Should give 10 volt. So plus 10 volt would be the correct answer here. So thank you. Dear students, you are suggested to watch all the video sessions that are already been uploaded in this particular channel, and these sessions would be based on the PYQ series of SSC-JE, and it would be on all the topics, all the chapters for your electrical engineering. Okay, thank you. Please do like, share and subscribe, and don't forget to press the bell icon for further notifications and updates. Thank you.